Hello and welcome to this webinar on the exciting new features in nRF Connect SDK version 1.7. My name is Bjørn Kvåle. I'm a product marketing engineer at Nordic Semiconductor, and with me today I have Paul Kostnes, a technical marketing manager on short-range wireless, and I also have Joakim Tønnesen, a technical product manager for Cellular IoT. Just some quick practicalities before we get started with this webinar. The duration will be approximately 45 minutes for the presentation, and then we'll have a 15-minute Q&A. We do have a few less slides than normal, so we may have a slightly shorter presentation, but then we'll have a bit longer Q&A. So if you have a lot of interesting questions, just feel free to ask them, and we'll have a bit more time than normal for that. Questions are encouraged. Please type the questions in the top of the right sidebar. So I see a lot of you are very active on the chat. The chat should not be used for questions. If you look in the top right corner, you should be able to, you can type a question in there. All questions are anonymous, but try to keep them relevant to the topic at hand. And then we will answer the questions towards the end during the Q&A session. The chat is not anonymous and should not be used for questions. And if you do have any more questions at the end of the webinar, feel free to go to Nordic DevZone. And last but not least, a recording of the webinar will be available together with the presentation at webinars.nordicsemi.com/on-demand. And we will also, the presentation will be given in PDF format, so you can click on all of the links that we provide. So just a short agenda. I will give a short intro to the nRF Connect SDK and basic terminology, along with some third-party integration we have. And then I'll hand over to Paul for the short-range update on this version 1.7. And then last but not least, Joakim will do the Cellular IoT update. And then we'll have the Q&A. So a bit intro on the Nordic communities. We do have webinars, which are mainly technology intros and trainings. So it goes from, our product portfolio all the way down into deep dives with the different protocols and how to get started developing. And that can be found at nordicsemi.com/webinars. We also have the Nordic Developer Zone, which is basically our support portal. So it's kind of similar to Stack Overflow, just for our product portfolio and embedded programming. It is both the tech support center and online community. And as you can see from the numbers there, we do have a lot of users and a lot of posts and a lot of Q&As. So in the last 6 months, we've had 3 million page visits approximately. And that can be found at devzone.nordicsemi.com. And we do have roughly 30-35 engineers working full-time on the Nordic DevZone. So we're very proud of the level of support we give all of our customers. I see someone's already started using the chat. Please do not use the chat for questions. Please, top right corner, you can put your questions in there. And last but not least, Nordic GitHub. So there we have a bunch of different repositories, mainly written in C, C++, but we do also have Python and JavaScript. So just go to github.com/Nordic Semiconductor for more on that. So now on to the first bit, nRF Connect SDK intro and basic terminology. nRF Connect SDK is all in one place. So before the nRF Connect SDK, we had the nRF 5 SDK, and that was, I do have a slide on that, next slide, I believe. But there we had 4 different SDKs for the different protocols. Now we've unified that all into one code base. So we do have one code base and toolchain for the nRF 91 series cellular and the short range nRF 52 and nRF 52 series, nRF 53 series and nRF 52 series. And then we also have the nRF 21 series, the radio front-end module, so the range extender. And this code base, so the nRF Connect SDK, is optional for the nRF 52 series as of version 1.3.0. So you can, for the nRF 52 series, you can choose whether you want to use the nRF 5 SDKs or you want to use the nRF Connect SDK. And protocol support, we have Bluetooth Low Energy, Bluetooth Mesh, Thread Zigbee, and also LTM, Narrowband IoT, and GPS support. For the nRF 52 series, you do have the nRF 5 SDK, which a lot of you might be familiar with. That is very good if you do not require a real-time operating system, and also if you're used to this SDK and don't require the newer features. So those are the features after Bluetooth 5, Bluetooth Mesh 1.0.1, Thread 1.1, or Zigbee 3.0 release 22. So for the 52 series, the nRF Connect SDK support is optional, but the nRF Connect SDK will support newer features after Bluetooth 5.0, Bluetooth Mesh 1.0.1, Thread 1.1, or Zigbee 3.0. So basically, the newer features are being released in the nRF Connect SDK. And once we hand out the presentation, you can see we have a statement on Nordic Dev Zone comparing and contrasting nRF 5 SDK and nRF Connect SDK. So that goes into a bit more detail if you're interested in that. And like I mentioned before, for the 52 series, you do have these 4 SDKs that are supported. So you have the nRF 5 SDK, nRF 5 SDK for Bluetooth Mesh, nRF 5 SDK for Thread Zigbee, and also the nRF Connect SDK. But I would say, like, if you're only getting started with Nordic now, and you haven't used the nRF 5 SDK before, it's probably a good idea to get started with the nRF Connect SDK. That is our future-proof SDK. Code base-wise, so on the nRF Connect SDK, you have app code, connectivity protocols, wireless stacks, and peripheral drivers. The code is organized into 4 main repositories. And if you look at the figure on the right-hand side, you can see the blue layers, that's the Nordic layers, and then the purple layers, that is the open source layers, so the open source code. And so you have 4 main repositories, but you also do have some other repositories. So we have a repository for Matter and Trusted Firmware M. But the 4 main repositories are nRF, which is where we have applications, we have samples, and also connectivity protocols. So that can be, Thread, Zigbee, Bluetooth LE, Bluetooth Mesh, etc. Then you have nRF XLib, which has the peripheral drivers and stacks. So essentially, nRF XLib is, the non-RTOS. So it's RTOS independent libraries and modules. So that can be, for example, crypto, NFC, BSDlib, etc. Then we have Zephyr repository. And just a quick intro. So a repository is essentially just a different folder. So when you have an nRF Connect SDK folder underneath, you will see these 4 different folders and a few other ones. Then we have Zephyr repository. That is where the real-time operating system is located, and also board configuration. And last but not least, MCU boot, which is a secure bootloader. And yeah, so on the right-hand side, you can see the different layers. Nordic applications, that's where we have, the different samples and applications where you can easily get started. So you don't need to write all of the code yourself. And of course, I mentioned the other things there. But these layers, so the what is sort of beneath these layers here, that changes quite often because we do, it's agile development, and so that can change quite often. Let's see. Next slide. So just some basic terminology. Git, hopefully most of you are aware of what Git is, but for those of you that are not, it's an open source distributed version control system for managing source code changes. It's well established in the developer community. Then you have West, which is a command line tool for multi-repository management and also building and flashing of examples. And then we have, like I mentioned already, repository is essentially just a version controlled project folder. So for example, when you do download the latest version 1.7 of nRF Connect SDK, you will see different folders. So among others, nRF, Zephyr, nRF xlib, etc. And every code commit that someone does, that a developer does, creates a repository version with a unique SHA identifier. So SHA stands for secure hash algorithm. It's basically just a long jumble of words and numbers. Well, not words, letters and numbers. Tag points to a specific commit SHA identifier that is immutable. The good thing about a tag is it is human readable version reference. So that basically means, so version 1.7.0 is a tagged version of nRF Connect SDK. Whereas if you look at the master branch, that is always the most recent commit SHA. So that's mutable. That means it's changing all the time. And that commit SHA is not human readable. So it doesn't have a nice 170 tag, for example. For the tag, Nordic product development support is available, so that we would like every developer to use a tagged version of the nRF Connect SDK. It has been tested more with CI testing, etc. But if there is a feature that you do not see in the latest tagged version, but you find it in the master branch, you are able to check out the master branch and start testing the newest features earlier than having to wait for the next tag of nRF Connect SDK. So just a bit about managing source code and configurations. We do have, like I said, West, the multi-repository management tool. That's how you can clone and update. You can see on the figure below in the left-hand corner, you have the nRF Connect SDK with the 4 main repositories. And then you can add your own code outside of that. And that then becomes the code base. You have the west.yaml file there. And then after that, you can use kconfig for source module and feature configuration for compiling. So that's how you configure the features. So if you want to use, say, GPS, then you can configure that inside the kconfig file. And then from that code base, you can then, depending on what features you need, you can make different applications. And then last but not least, you have then the device tree. So for the target board. So depending on which target board on the device tree, you have DTS and DTSI files, and that then describes the different hardware. It lays out the GPIO pin mapping, etc. So the DTS file will be slightly different if you're using, say, Thingy 91, Nordic Thingy 91, or let's say a 52A40 DK, or the wireless mouse reference design. So that's just a very short intro, but we do have a lot more in-depth documentation describing this. We also have webinars that we go into detail on this. And we also have DevZone blog posts, which go into a lot of detail on this. Release cycles. So the release cycles are every quarter. So we just had a release last Thursday, I believe. It is publicly hosted on GitHub, so you can always click on that link there to see what the latest status is. And before a tagged release, we'll also have release candidates. So we normally have at least 1 or 2 or 3 release candidates, and that can be found also on GitHub. If you go to just that link and you go to the tags, you can find it there. And And of course, if there are any major bugs, we do release fixes as needed. And the long-term supported releases can have fixes applied and delivered after new releases too. Right, so you can see on the graph on the figure on the right, you can see the major tag on the left-hand side. And if there is a minor tag after that has been released, but there has been a bug found on the major tag, it may have, a different branch with the fixes there. And yeah, and the latest, the master, you can see on the right-hand side of that figure, that is always the last up-to-date version of the nRF Connect SDK. So that is where the developers are often found committing changes. Yeah, and the latest development version is available. And like I said, the version control management is done with Git. So that's how you can manage new versions. And the tool Git also supports merging if you need to do that. Just quick on supported for development versus production. So we often write this in our release notes, in our documentation. And if the feature says supported for development, it can be used for development, but it's not recommended for volume production. Whereas features supported for production are maintained and are suitable for product development. Going back to supported for development, technical support is available on Nordic Dev Zone or via one of our FAs. Reported bugs may not be resolved until it is supported for production. The implementation may be partial, so it may be incomplete. The APIs may also change before they go to production, and the verification is also incomplete. So this is essentially very suitable for prototyping and evaluation. And if it's supported for production, technical support is also available, as it is for supported for development. But the reported critical bugs will be resolved in both master and latest tag version of nRF Connect SDK. There, the implementations are complete, and it is essentially verified for product development. So just to sum it up quickly, supported for development, very good for prototyping evaluation, whereas supported for production is very suitable for integration and end products. So once you do go into volume production, you want to make sure the feature is supported for production. So quickly on the nRF Connect SDK documentation, I provide a link to the documentation. It's just developer.nordicsemi.com, essentially. You can click on the arrow in the top left to choose the documentation tag. So here we can see 170, so that's the latest tagged release of nRF Connect SDK. 1799 refers to master branch. But of course, if it's, the next version 180, then the master branch would be 1.8.99. So as soon as you see a 99 at the end, that's essentially the master branch. And if you look at the figure on the right, on the blue image there, you can see latest. So once you basically click on that little arrow, the downward arrow between after 170, then you can switch between the different tagged releases and also the latest version, which is that's just the master branch essentially. And on the bottom left-hand side of the documentation, that's where you can switch between the different repository documentation. So if you want to switch, again, you click on the arrow, and then you can switch between nRF repository. If you want to look at the Zephyr project documentation, you can click on that, etc. And just a quick mention on third-party integration in nRF Connect SDK. I will soon hand over to Paul after this. We do have memfault support as of version 1.6.0. So that is a connected device observability platform for nRF Connect SDK devices. So that essentially provides continuous monitoring. You can view device and fleet level metrics. So if you want to look at battery health, connectivity, you can see that real time within dashboards, and you can also have customized charts and alerts for Nordic. Very cool. You can do remote debugging, so you can resolve issues very efficiently with automatic detection, deduplication, and also any actionable insights sent via the cloud. You also have the possibility of doing over-the-air firmware updates. So if there are any bug fixes, you can deploy the updates directly to customer devices in the field to easily resolve the issues. And we do have native integration via the nRF Connect SDK as of version 1.6.0 to give, and we do give Nordic developers access to Memfault, or Memfault gives Nordic developers access on 100 devices for free. So if you click on the link there, the setup takes roughly 5 minutes. So yeah, if that sounds interesting, feel free to get started with that. And one last thing, we do also have a webinar on Memfault. So if you do want to learn more about Memfault, go to webinars.nordicsemi.com, go to On Demand, and there you can find a more in-depth webinar explaining what Memfault is and does. So without further ado, I'll hand it over to Paul for the short range updates.
Yeah, hi. So you can hear me?
Yep.
Yes. So one of the key new features we added to the version 1.7.0 is support for the nRF 21540 front-end module. So this is a new device in our portfolio. We had it available. We launched the device end of 2020. But now we have also got all the software support in place, and we will soon release kits with the 21540 into the market. So this is a front-end module which basically supports all of the radio protocol that we are running on the 52 and the 53 series. So we do Bluetooth low energy, we do Bluetooth mesh, we also do Thread, and we do Zigbee with it. So this is a device that you will typically use if you want to have a longer range of your Bluetooth or Thread or Zigbee communication link. And we are able to do that by increasing the output power. So the front-end module itself supports up to 21 dB of output power. If you compare that with the 53 series where we have 3 dBm and the 52 series where we support 4 to 8 dBm, you can see we get a significantly higher output power with this one. Also, we have a what's called a LNA, a low noise amplifier, which improves the RX sensitivity with up to 5 dB, depending on the device. It will depend on the device how much improvement you get. By using this one, we will be getting, if you combine it with the 52 or a 53 device, we get everything between 6.5 to 10 times longer range in line of sight with the front end module compared to not using it. So it gives a significant better range of the system. Next slide. So to be able to use the front-end module, since it has both a low power mode, it also has the transmit mode and the receive mode, you need to be able to control it. And this needs to be controlled together with the radio activity going on in the wireless SoC. So the device itself supports GPIO control to be able to change between the RX, the TX, and the low power mode and so on. And we also has an SPI interface where you can use the SPI interface to control the entire device, but you can also use the SPI interface to just take care of the gain setting and so on. The device has a programmable gain, and then you will use the GPIO control to do the switch over. And as I said, there is a possibility to adjust the gain in the device. It comes with 2 pre-programmed gains for 10 dB and 20 dB, but you have 32 steps where you can switch it up and down. And the 2 modes can be controlled directly through the GPIO interface, but if you want to go for the fine gain control, then you will need to use the SPI. It also does antenna diversity support, which is something that we see frequently used in Thread and Zigbee. And then in the SDK, we do have support today for GPIO control. So we're using the GPIO control to do the configuration of the device and everything. We are looking into doing SPI control at a later stage. Next slide. So to be able to demonstrate how this works, we are going to release something called the we are using pin control, as I said, in 21540. There is no SPI support as of today. Adding the SPI support for setting static gain and so on is something that can be done on the application layer, but we will not be supporting using SPI control for changing between RX and TX mode, for instance. We do have support for Bluetooth LE, Bluetooth Mesh, Thread, and Zigbee already in nRF Connect SDK version 1.7. This is supported through the multi-protocol service layer. So the multi-protocol service layer is a nRF lib library that comes with the nRF Connect SDK, and it provides several different features. One of them is to support for doing multi-protocol, as the name says, where you can do Thread, Zigbee, and Bluetooth, and you can do them concurrently. But also a new feature with the multi-protocol service layer is that we integrate the support for the front-end module control. We have support in there today for the 21540 and also for a generic support that can be adopted for other front-end modules than the nRF 21540. But to be able to utilize the feature, you will need to configure your projects to use the MPSL. And this is a simple setting. So it's a setting called MPSL_fem. Setting this to true will pull in all of the features needed to do that. So next slide. So to make it easier to do demonstration and to test out the code and work with the code, we will have a kit called the nRF 21540 DB. This is not currently available. It will be available shortly. This one consists of two different boards inside the package. So it's one package called the 21540 DB. Inside the package is the 21540 DK. This is a development kit. As you can see on the picture, is very similar to all our other kits. This is basically the 52840 DK, but we have removed the quad SPI flash present on the 52840 DK to fit in the 21540 front-end module instead. We needed this to be able to get the pin count to go up. This is supported as a build target in nRF Connect SDK. So if you try to build any sample in a Connect SDK and you choose the 21540 DK as the target, we will automatically add the MPSL support for Bluetooth, for Thread and Zigbee and so on. And it will be part of your project and you will build it and the front-end module will be there. Have in mind that for Bluetooth, we only support this with the Nordic soft device controller. So there's no support for the front-end module together with the Zephyr controller. So if you want to use the front-end module and if you want to use MPSL, you have to use the Nordic soft device controller. One of the additional feature updates we have done to the nRF Connect SDK version 1.7.0 is that the default controller for Bluetooth Mesh is now also the Nordic soft device controller. So this is why we can be able to support also Bluetooth Mesh with the front-end module. We also do have direct test mode and radio test example support for the front-end module for the DK. There are some samples for doing direct test mode and radio test examples in the nRF5 SDK with the front-end module, but it will never go any further than having those two samples in there. Next slide. The second board inside the nRF 21540 DB is the nRF 21540 EK. So this is, as you can see on the picture, a shield that will plug into our DKs. This is a shield form factor, so it fits directly into all of the 52 or 53 series DKs, but you can also use it as a standalone board if you want to just do measurements on the radio front-end module. As you can see, the SMA connectors is easy to connect it to lab equipment if you want to do measurements on it. The reason why there are 3 connectors on it is because there is an input that goes to the wireless, to the RF SoC, and there is a dual antenna output, so ANT1 and ANT0. So this is supported as a shield in the nRF Connect SDK. And this means that if you have a project which you build for a nRF52 DK or nRF53 DK, you can click in and says that you want to add the shield. As soon as you add the shield to your project, we will configure it to use MPSL, so you get the front-end module support in. There will be an overlay file that comes with the pin configurations and everything you need to set up to make it work. And because of this, adding the shield to another DK is fairly easy to do. And you can also use this as a template for adding nRF 21540 support to your custom PCBs, because you will be able to see the overlay files that comes with the shield, what features needs to be in the project, what descriptions needs to be added to make it work. Okay, I think that was all for my side.
Okay, then it is time for the Cellular IoT updates. Today I wanted to start out with an overview, providing you with the insight on what we actually offer when it comes to Cellular IoT in Nordic Semiconductor. First out, we have the nRF 9160, which is the system in package containing the cellular modem capable of LTE-M and narrowband IoT, and also with integrated GPS support. In the same package, there's this Cortex ARM M33 application processor, and this is the hardware basically. Then we have the nRF Connect suite, which contains tools for desktop, it is cloud and mobile applications, and last but not least, the nRF Connect SDK, which we are going to talk more about today. Then on the other side, we have the development kits, 9160DK. In addition to that, we also have the Thingy 91, which is hardware platforms and development platforms with the 9160 on board. So over to the SDK side. So as you see here, the 9160 has both the application MCU and the modem core inside. And if we look at the modem firmware side of things, the lower part of the right-hand figure, it supports LTE-M, narrowband IoT, and GPS. It is a closed source pre-compiled image that can be downloaded from nordicsemi.com, and it handles everything up to and including the TLS and DTLS layers. Then in between the two cores, we have a shared memory, and on the modem or on the application core, we have the modem library running, which is the interface between the application and the modem. On top of that, again, we have the internet protocols or middleware, which is basically then using the TCP, UDP, TLS, DTLS sockets that are provided by the modem library, and implementing stacks like HTTP, MQTT, co-op and lightweight machine-to-machine, etc. on top of that. Then we also have a bunch of ease of use utilities like the link controller, the AT command libraries, GPS drivers, this kind of things. On the left-hand side, we have the carrier library, which is used in those scenarios where you have a mobile network operator with a device management platform. Those are using lightweight machine-to-machine and require some certification. So we have a closed source binary also for that. On top of everything, we have a wide set of different libraries and modules ranging from nRF Cloud, library, AVS, Azure, location libraries, libraries for doing photo, makes it easy to handle 80 commands, and in general interact and make your application. On top of all of this, again, we have all the application and samples we provide. To mention a few of them, we have the asset tracker, we have something called Serial LTE modem, 80 client, samples for assisted GPS, samples for more or less everything you would need. In addition to the samples we provide in nRF Connect SDK, you will also get a bunch of samples directly imported from the Zephyr operating system. Then over to the updates in the new version of nRF Connect SDK. First out, we have the modem library. It's now been updated to version 1.3.0. It contains a new API for handling 80 commands. 80 commands are essentially a set of modem instructions that are used to configure the modem, establish a network connection, or in general execute operations. It's used to receive modem and connection status information, and for the full set of supported 80 commands, I've included a link here to the 80 commands reference guide that have all the details about the different 80 commands we support. We have also added a new API for modem delta firmware updates. So the modem library basically supports delta updates of the modem firmware. Delta update is an update that requires downloading only parts of the modem firmware that have changed. So instead of downloading the whole firmware, you can now only download a part of it. Such updates will save significant amount of time and bandwidth. And during this firmware delta update, the application transfers the firmware image into a flash memory in the modem, which is known as the scratch area. Once the update has been transferred completely, the application schedules the update of the modem firmware, which then happens next time the application boots the modem while calling this nRF modem init function. Yes, and this modem update, of course, also includes rollback functionality. Then we have the nRF Cloud services. So we recently launched nRF Cloud location services. So this time in this release of nRF Connect SDK, we added also a guide how to use nRF Cloud with nRF Connect SDK. There is this updated nRF Cloud library that now contain all the functionality that's also part of the location service, like assisted GPS, predicted GPS, and cellular positioning using both single cell and multi-cell technologies. So when it comes to assisted GPS, the assisted GPS library enables application to request and process assisted GPS from nRF Cloud. This library is add-on or enhancement to the nRF Cloud library. The use of assisted GPS is something that reduces time for a GPS device to estimate its position, which is also called time to first fix. To get a position, the GPS needs information such as the satellite orbital data, exact timing, and rough position estimates. and GPS satellites broadcast this information in a pattern which repeats every 12.5 minutes. Meaning that if you are to get this data directly from the satellites, it would take a lot of time. The assistance service basically offers you to download the same data through the LTE link instead, meaning that it will go much faster. Then over to the predicted GPS. Predicted GPS is intended for, I would say, specific use cases. It's not targeting the general use cases that normal assisted GPS works with. Predicted GPS is designed for devices that are frequently disconnected from cloud but need periodic GPS fixes as quickly as possible anyway. Meaning that you can download a larger portion of assistance data also into the future. Normal assisted GPS is valid, assistance data is valid for 4 hours, while the predicted GPS data can be valid for up to 2 weeks. Then the cellular positioning library enables applications to request crude position from nRF Cloud, then only based on the nearby cell towers, meaning that you enable extremely low power positioning without the need to enable the GNSS receiver or GPS receiver at all. Then we also have quite some examples, applications and samples using this service. First out is the Asset Tracker version 2. This implements an end-to-end asset tracker, so it's worth checking out if you are building your own asset tracker. We have a more specific sample for assisted GPS, which is called AGPS. There you can test out and try the assistance data from nRF Cloud. We also have a multi-cell location sample, which is using the cellular positioning service. And we have also added the support for the nRF Cloud location services into the serial LTE modem application. Then we have the supported modem firmware version is now 1.3.0. I have added a link here to where to download this version of the modem firmware, and also you can find detailed release notes inside the zip folder. On infocenter.nordicsemi.com we have a compatibility matrix which will show you which versions of nRF Connect SDK works with which version of modem firmware, and we have also the nRF 9160 certification webpage, which shows you all of the certifications that we have currently done. And we are continuously working on increasing the certification scope. Okay. That was all I had for today. So now it is time for Q&A.
If you want to sign up for more webinars, if you enjoyed this webinar, feel free to go to webinars.nordicsemi.com. We will have a webinar roughly every week until Christmas. If you do have any more questions after the webinar is done, feel free to get technical support and also join our community at devzone.nordicsemi.com. And if you want to find out more about our products and services, go to